Pascal's triangle. Did you recognize the pattern that you can find the next row by adding? Since we're collecting things from all over the place, would you like this as well? Oh yeah, that's mine. You add the 2 above it to get the next row. Very nice. And in this, there's combinations. There's a way that you can memorize the position and the position and the row number to figure it out. However, I find it a lot easier just by taking one of these numbers, like 4. It is very easy to remember that that's 4, choose 1. And if you know that that's 4, choose 1, then here's your 4, choose 0. There's 4, choose 2. There's 4, choose 3. And this one would be 4, choose 4. And you can find them quite easily without having to remember, how would I figure out what this 10 is? Well, I'd go beside and, hey, there's 5, choose 1. So this has to be 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. So that's the connection between Pascal's triangle and combinations. And now we're going to see how this appears in algebra. So we're going to look at a binomial, x plus y, and we're going to put it to different exponents. We'll start at 0, then we'll go to 1, then we'll go to 2, then we'll go to 3, and we'll go to 4. And we're actually going to start off probably with the squared. The squared one, you know how to do x plus y times x plus y. You could do all the arrows, and you would get x squared plus 2xy plus y squared. I'm just going to add that in the y squared, we could call this a 1y squared, and we could call this 1x squared. Now, anything to the power 1, that's just itself, right? So this one would just be x plus y, and we really have 1x plus 1y. And what does an exponent of 0 do to something? Makes it equal to 1. And then when we get x plus y cubed, we're going to get 1 x cubed plus 3 x squared y plus 3 xy squared plus 1 y cubed. There is a pattern happening with the numbers out in front. Some of you, I saw by the noises you made, you saw it. And there's also a pattern that's happening with the exponents. Can you figure out the pattern to write the next one out without actually having to multiply it all the way out? So write it down on your own, and then when you're ready, you can look up and see if you got Oh, thank you. Someone noticed something. You made a little typo. There we go. So a little bit of explaining what's happening here. Why does Pascal's triangle show up? Why do those numbers in the exponents show up the way that they do? And some of it we can connect to our very first unit, our very first chapter, chapter 1, not our first chapter that we did, but the polynomials chapter, if you were multiplying x plus y times x plus y times x plus y, does it make sense that your first ones would give you an x to the 4? And does it make sense that your last ones would give you a y to the 4? And we used our first and our last ones a lot in that first chapter, but we didn't worry about the middle on how things work. So, the idea is as follows. When we have an x cubed y, you can make an x cubed y by using this y, and then this x, and that x. You could also get an x cubed y by using this y, in which case you'd have to use this x, and this x. We could also have chosen this y, which would mean this x, this y, and this x. And there are how many y's? There are 4. In order to get an x cubed y, you need to choose 4 y's. You needed to choose one of them. Which y are you going to use? Because when you're multiplying this out, something from each term gets multiplied by something else in each term all the way through. So to get an x cubed y, you have to say, well, which y am I going to use? I have 4 of them, I'm going to choose 1. Next one, to get the y squared, now I have 4 y's, I need to choose 2. 4 choose 2 is 6. That's why there's going to be 6 x squareds, y squareds. So that explains the combinations and why it shows up when you're multiplying this out. And this pattern, a couple things to notice in the pattern. 1, did you notice your powers of x just kept going down by 1 until they disappeared? And you started with 0 y's, and they went up by 1 until you got to y to the 4th. And in any specific term, the exponents always added up to the 4 anyways. Like here's 3 and 1, 2 and 2, 1 and 3, or just the 4. They'll always add up to the 4 anyways. Another thing that's going to be really important for us to notice is that when you expand something, for example, when I expand x plus y squared, and this is the one that I use to remember the pattern because you've multiplied squared binomials out so much. If you have to multiply that out, does it make sense you get 3 terms? That's 1 more than the exponent. When we got to x plus y to the 4, there's 1, 2, 3, 4, 5 terms. Always 1 more than the exponent. That's going to be really helpful because it's going to tell you which row in Pascal's triangle you should use as a starting point. So now we're going to go to some questions with this. We'll go to example 1. First thing I'm going to look at is that the exponent is 4. That tells me I'm going to have 5 terms. In Pascal's triangle, how far do I have to go before I get 5 numbers? Here I am, 1, 4, 6, 4, 1. That's when I get to 5 numbers. So if I want to do the expansion of 3b minus 1 to the 4, I'm going to start by just spacing this out. 1, 4, 6, 4, 1. Those will be my coefficients of my 5 terms. Again, if I think of 3b minus 1 times 3b minus 1 times 3b minus 1 times 3b minus 1, does it make sense that your first one is going to be 3b, 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 3b? It's going to give you 3b to the 4. And then the second one, your 3b goes down by 1, and you have the minus 1 once. Then we're going to have the 3b squared and the minus 1 squared. Then just the 3b and the minus 1 cubed. And finally, the last one is just going to have that minus 1 multiplied by itself 4 times. That's expanding it. We still have to simplify. Order of operations, you know you have to do exponents first. So some of you might want to do more mental math all at once. I'm going to take my time. I'm just going to do exponents first. 3 to the 4 is 81. And then b to the 4 plus 4 times, here I have an exponent, I'm going to get 27b cubed, still times by that minus 1. 3b squared will be 9b squared. Negative 1 squared will be positive 1. Negative 1 cubed will be negative 1. And negative 1 to the 4 will be positive 1. So I did all of those exponents first. And now, if I have any multiplication, I can finish up. So 81 b to the 4, negative 4 times 27, negative 108 b cubed, plus 54 b squared, minus 12b plus 1. There is our final simplified expansion. And you have to decide, was that quicker than actually multiplying this out? Right? If I were multiplying this out the old way, I'd probably multiply these two together and get 9b squared minus 6b plus 1. And these two together would be 9b squared minus 6b plus 1. And then you see that you'd have to do this to everything. This one to everything, and the 1, whoops, to everything. Write all that out and combine all your like terms. I think this might be, it might be shorter. And this was only a 4. Once we get to ones with 10s or 15s, don't worry. We're going to do something, when it gets to the really big numbers, they don't ask you to do it completely. Just a little bit less. But we're ready to see, questions for practice on this one are 3 and 4.